Hello students, in this lecture we'll cover the remaining part of the signal designing with the practice question and last topic of the control devices, that is the traffic island. Let's start with the question of signal designing, the trial cycle method. The question I already gave you. I hope that you must have tried the question. If anybody of you have got the answer, just message me the solution so that I can get it checked. Now, in this question, what we have to do is that in the last class, we have covered two different methods. One was the approximate method. And another was the Webster method. Both of these methods were basically the signal designing method, in which finally what you have to calculate is that cycle time is what we want from both of these methods. To calculate the cycle times, the procedure was that you have to calculate the green time on road A, you have to calculate the amber time. In these questions, when they are asking the green time, they will be providing you with the amber time already in the question. So you need not to calculate the amber time separately. How to calculate the amber time, you already have seen that in the last class. But here what we have to do is that we have to just calculate the green time. To calculate the green time, what you have to use? You have to use these two different methods. We will calculate the green time for one road, we will calculate the amber time for one road, then you have to add both of them to get the red time on another road. Similarly, you will calculate the green time on another road and amber time on another road, and then you have to add them to get the red time on another road, which means that if you want the cycle time, then this will be GA plus AA plus RA, where RA you can replace it by GB plus AB. So basically here in this particular relation, what we have to do is that we have to just calculate the green time. Now, let's see the question. In this question, they are saying that we have two roads. This is road A, and we have road B. We have two roads, road A and B. Just draw the figure. You will understand from the figure only. We have two different roads. One is road A, another is road B. We will draw it here. This is road A. And another is road B, which is here. This is road B. This is road B. Now, as you have two different roads, one is road A, another is road B. This is road A and road B. Now, in this question, they are saying that road A has 6 number of lanes. This is 1, 2, 3. And the remaining will be 1, 2, this is 1, 2, 3, 4, 5, 6. 6 number of lanes on road A. And on road B, they are saying that it is having 2 number of lanes. The total width of road A, this is road A, the total width of road A is given to us. The total width of road B is also given to us. The total width of road A, which they have provided us with, is 19 meters. This is the total width. And they are saying that the traffic is moving in two directions. In both of these roads, the traffic is basically two-way. So it means this will be somewhat kind of divider or something. Now, this section of road, this is having a width of 7.5 meters. This is having a section of 7.5 meters on which two lanes are present. They're saying that in this road A, the traffic is moving and the traffic they have provided us in only in one direction. They're saying that the traffic in this direction, this is the traffic which they have provided us in this direction, and here they have provided us the traffic in this direction. So they are saying that the traffic is moving in both the direction, but in the question they have only provided us with the one direction traffic. Here this traffic is 1360 vehicle per hour, which is moving in this particular section of road. In this direction, दूसरा traffic इस direction में जा रहा होगा जिसकी हमें information provide नहीं की गई है. In this case, they are saying that the traffic is moving here in this direction, and this is 310 vehicle per hour. Only the traffic in one direction is provided to us. Fine. The amber time, this is road A and this is road B. The amber time for both the roads are also given to us. The amber time for road A, this is 4 seconds. And the amber time for road B is also 4 seconds. They have provided us the amber time also. Now, what they are saying is that, they are saying that the number of phases is 2. The number of forces are 2. We have 2 phase system. And the total red time they have provided us with 16 seconds. This is the total red time. These are the things which they have provided us in the question. Now what you have to do is that you have to calculate the cycle time and design the signal system. Now just see one thing here. they have provided us with the traffic only in one direction. In this direction, they have not provided us with the traffic. It means that we cannot design the signal properly, but still we can just design the signal theoretically by applying the concept. Fine. बट ऐसा नहीं होगा कि आपकी डिजाइन आप जाके रोड पे उतार दो कि कल मैं सिग्नल बना के रोड में लगा दूंगा. ऐसा नहीं है. दिस इज जस्ट अ थियोरेटिकल डिजाइन व्हिच इज जस्ट टू शो ऑफ दैट you know the procedure. You have to just explain the examination that you know, examiner, that you know the procedure to design the signal. Fine. So just we have to do that thing only here. Fine. Now, how to design? So first of all, what we'll be doing, we'll be applying the approximate method, and then we'll be applying the Webster method. Let's see that. Let's do one thing. Just remove it here because we need not to just consider this portion of road. We are already considering the portion which is present upward. Now, let's see that. First of all, we'll be using approximate method. Now, what is approximate method? Approximate method says that you have to first calculate the green time for the pedestrian to cross the road A, which is equal to 7 plus WA divided by 1.2. Remember the last class. Remember the last class. Just see here. What exactly will be happening? The pedestrian will be standing here. He wants to cross the road A. Now, just remember one thing. You will make the pedestrian cross the total road. It means that the pedestrian has to start from this point and he has to reach this point. You cannot leave the pedestrian here in between. What students do sometimes is that they just consider this much portion of width. They just consider the half portion of the width. But it is not the actual case. The actual case is that you will not consider the 9.5 meter width. Fine. Why you are not considering the 9.5 meter width? If you will consider the 9.5 meter width here in place of the total width, then what you are exactly doing is you are leaving the pedestrian here and then you are starting the traffic. तो pedestrian बेचारा यहाँ अगर खड़ा हो गया तो ये इसके आगे पीछे चलने लग गया तो ये कंफ्यूज हो जाएगा, मैं जाऊंगा कहीं का नहीं रहेगा. It means that you have to make this pedestrian cross the total width of road, even the divider is present or not present. It is of not any importance. You have to make the pedestrian cross the total width of road, that is of 19 meters. It means that here the green time for the pedestrian to cross the road A, तब तक आपको ये अलाउ नहीं करना है यहाँ पे ट्रैफिक, क्योंकि ये बेचारा यहाँ से यहाँ जा रहा है. You cannot allow this traffic to move like this, because if this traffic started moving, then accident will be there. So this will be 7 plus, what is WA? WA is 19 divided by 1.2. So you have to just calculate this value. This value will come around. You can round off the exact value. This will be 22.8 something, 83 seconds, and you will round it off to 23 seconds. You will round it off to 23 seconds. Similarly, this is what? This will be equal to the red time on road A. This will be equal to the red time on road A. Similarly, you will calculate the green time for the pedestrian on road B. This will be equal to 7 plus WB divided by 1.2, which will be equal to 7 plus. Now, what is WB? WB is this much portion of it. Now, this pedestrian will try to cross this particular road. This is road B. And when he will try to cross this road B, the total width he has to cross is 7.5 meters. This is 7.5 divided by 1.2. The value which you will get is here. This will be 13.25, which will be around 14 seconds. You can round it off. This will be equal to RB. Now, what exactly you want is that you want to apply the approximate method. Now, what the approximate method says is that this RA is equal to GB plus AB. It means that which is RA? RA is equal to 23 seconds. It means that this GB can be equal to 23 minus AB to AB is 4 seconds, which is equal to 19 seconds. Similarly, this RB, this will be equal to GPB, which is equal to 14 seconds. It means that this 14 seconds will be equal to GA plus 4. It means that the GA value you can calculate, and this value will come to be 10 seconds. It means that you have the calculated values, 19 seconds and 10 seconds. Now, how to apply the approximate method? As I told you in the last class that whenever you want to apply the approximate method, what you have to do is that you have to consider the greater value of the green time, and then you have to calculate the value corresponding to that greater time depending upon the amount of traffic. Now, what is the amount of traffic? Amount of traffic per lane on road A. They have provided us with the amount of traffic, that is 1360 vehicle per hour, which is moving on how many lanes? This is 1360 vehicle per hour. This is moving on how many lanes? Remember that we have to design for a single lane. It means that this traffic is moving on 1, 2, 3, 3 number of lanes, and you want the traffic for a single lane. So ये हो जाएगा, this will be divided by 3, which will be equal to around 454 vehicle per lane. Remember that vehicle has to be rounded off. Point में vehicle नहीं होता है. Similarly, NB. The traffic which they have provided for the road B is in this direction. Now, in this direction, how many number of lanes are present on which this traffic is being distributed? Only single lane, because they have already provided us with the traffic distribution for this lane only, which is a single lane. समझ में आ रहा है ना? इतना ट्रैफिक है, ये वाला नहीं दिया, इतना दिया, यहाँ पे इतने में ही ये तीनों आ रही थी. It means that this NB value will be equal to 310 vehicle per hour, which will be equal to vehicle per hour per lane. 310 vehicle per hour per lane. This is the normal flow of traffic. It is a normal flow, not the saturation flow. Saturation flow value has to be used when you will be like applying the Webster method. Now, what you want is that you want to adjust the timing. How to adjust the timing? As I told you in the last class, you have to consider the greater value. What we are doing is that now we have calculated the normal values of traffic. Now, what you want is that you have to consider the greater value and then you have to go for the lower value. Now, GB value is 19 second, which is greater, and GA value is 10 second, which is lesser. It means that what we will be doing, we will consider the greater value. We will consider the GB value and calculate the lower value and calculate what? We will calculate GA dash value. It means that this GA dash divided by GB, this is equal to 454 divided by 310, because 310 is the value which is value for the road B. It means that here you will calculate GA dash. This GA dash value is 454 into GB. GB value we have used 19 second divided by 310, and this GA dash value is, when you will calculate, this is 454 into 19 divided by 310, this is 29 seconds around. 29 seconds. It means that when you are using GB dash equal to 19 seconds, then you want at least GA dash equal to 28 seconds. This is 28 seconds. 28 seconds. It means that for the 19 second value of GB, at least 28 second of GA dash is required. But here, what is the value? It is 10 second. It means you cannot use this value. The cycle time here will be 28 plus 4 plus 19 plus 4. This will be the cycle time. It means that if you want to calculate, as I already told you in the last class, you have to use the greater value only. This total value of cycle time, when you will calculate, this value comes to be 55 seconds. This will be the cycle time as per approximate method for this particular type of question. Remember that we are considering only single lane, also traffic in one direction. This is not the actual design, because in case of actual design, you have to adjust the traffic in this direction only, but that is beyond the scope of engineering or state services examination. So you have to use the question like this only. Fine. Now, the next part is the Webster method. The next is Webster method. You have to calculate the same thing by using Webster method. Now, Webster method is nothing. You will just do it yourself. I'll just apply and tell you the procedure so that you can just practice it by yourself. In the Webster method, what the case, you have to first calculate, you have normal flow values. NA is equal to 454 vehicle per hour per lane. We have NA values, that is normal flow values on road A. We have NB value is 310 vehicle per hour per lane. Now remember that in the last class I have just provided you with the table. You can note down that table on a paper when you will be solving this particular question. That table will be used for the calculation of saturation flow values per lane. Now, what is saturation flow values? As I told you, the saturation flow values depends upon the approach road width. If you want to calculate the saturation flow value, saturation flow traffic for road A, then for road A, the traffic is distributed over 3 lanes. But what you want the traffic to be distributed on a single lane, because you are designing for a single lane only. But for this particular traffic which is provided to you, the approach road width is 9.5 meter, 9.5 meters. Remember the table, as I told you, whenever the approach road width is greater than 5.5 meter, then in that case, saturation flow values will be calculated by multiplying the 525 values with the approach road width, 525 into 9.5. Fine. This value will give you, this is equal to 4987.5 vehicle per hour. Now you have multiplied it with 9.5. It means that you have just calculated the value for 3 lanes. But what you want the value for 1 lane. It means that we have to divide it with 3. It means that when you will divide it with 3, you will get the single lane saturation value when maximum amount of traffic will be moving on that particular lane. That value is 1663 vehicle per hour per lane. This is the maximum amount of traffic which will be present in the moving position on a single lane. Fine. Similarly, on road B, if you'll see that for road B, the approach road width is, this is the total width of 7.5. What is the approach road? Approach road width, half of that. That will be 3.75. It means that when you will see the table for 3.75 values, the value will be between 3.5 and 4. It means the saturation flow value will be the average value. You need not to interpolate because this is the mid value. एक 3.5 value पता है, एक 4 value पता है, 3.75 is the mid value, so need not to interpolate, you can just take the average. This is 1950 plus 1890 divided by through. These values are given in the table, you can just check the table. This will be 1920 vehicle per hour. Now how many lanes? Single lane. It is given for the single lane only because the approach road width is 3.75, which is having only one lane. See that? Here the approach road width is 9.5, which is having 3 lanes. That's why we have to consider it like this. We have to divide it by 3 because you want it for one lane, but the approach road width is considering it's accommodating 3 number of lanes. Here the approach road width is accommodating only a single lane. That's why we need not to divide it by any number. This is NA. You already have NA values. You have SA and SB values. Now what you have to do is that you have to calculate YA values. You have to calculate YB values. Remember that NA upon SA and B upon SB. Then you have to calculate Y values. This is YA plus YB. What you have to do is that you have to add up these of both values. Then you have to calculate the optimum cycle time, which is 1.5 L plus 5 divided by 1 minus Y. Now what is L? L is equal to 2N plus R. N is given to us 2. R is 16. It means this value will be 20 second. L is 20. You just have to put the values here. 5 you already have. Y values you have already calculated. You will get this value. After calculating this value, you will calculate GA and GB. The relations as I already have given. Now, by using these values, you can calculate the cycle time. Here the cycle time will be around 50 seconds. You can check and calculate and check the values. Fine. You have to calculate by yourself. I already calculated the SA and SB values. Now what you do is that, as I told you have to create a file. In that file, I just told you to write that OSD portion of question. That was an important question. In that particular file also, you just write this question properly. Just draw the figure. Just calculate the timings by using approximate and Webster method. Just write it down and keep that in your file. Fine. This is the good question. This question can be asked in the examination. Now, let's come to the another topic for today. That is the traffic island. That is the traffic island. Now, what is the traffic island? Traffic island is basically the raised portion which is present on the intersection, which can serve the different purposes. These are basically the road intersection raised portion, which is having a certain level more than the normal road level. These islands can be classified into different types. That is, they can be divisional island, they can be channelizing island, they can be pedestrian island, जो फुटपाथ होता है कभी कभी उठा हुआ देखा होगा. They can be pedestrian island. They can be the rotary island also. They can be the rotary island. Now, what is division island? Divider होता है, divider, road divider, which is dividing the traffic into two way. That is the division island, which is a raised portion. इस पे पेड़ भी लगा दिए जाते हैं. पेड़ क्यों लगाए जाते हैं? Trees क्यों plant किया जाता है division divider पे? जिससे जब आपका ट्रैफिक मूव करता है, वो ट्रैफिक इज मूविंग इन बोथ द डायरेक्शन, तो द लाइट फ्रॉम वन साइड ऑफ द ट्रैफिक will not reach the traffic which is present on the other side. Otherwise, it will become difficult for the driver to just move on that particular lane. If you're moving here, if the light from this is reaching this particular vehicle, then he will find it difficult to move. That's why the trees are planted here, so that they can absorb the light. Fine. What is channelizing island? Channelizing island are the light which move like this. Like if this is a road, you will provide a channelizing island like this. This channelizing island means it will move the traffic here. It will allow the traffic to move like this. It will channelize the movement. Channelize. It will not allow the traffic to move like here from here to here. It will allow the traffic to move from here to here. Similarly, it will allow the traffic to move from here to here. It is giving a proper channel for the movement. Pedestrian. Pedestrian island is basically the footpath. आपने देखा होगा road के side में there is a raised portion, that is a pedestrian island. Rotary island. Rotary island is an island which is constructed in the intersection with the number of roads are more 4 or more than 4 intersecting roads. Then you have to construct a rotary island. This is a rotary island like this. When the number of roads are at least 4 or more than 4, you can construct a rotary. This is a rotary island. Here the case is that only the clockwise movement is allowed. No super elevation is given in this particular island. The problem here is it requires a large area, which is the problem for the rotary island. Also, when the pedestrian मतलब पैदल चलने वाला ट्रैफिक, जिसके पास कोई गाड़ी नहीं है, ठीक, when the pedestrian traffic is large, then rotary can create a problem, because in this rotary island, The traffic cannot stop. Traffic has to move continuously. Now, if the person is standing here, he is a pedestrian and he wants to move from here to here, he will find it difficult because the traffic is continuously moving. It will be difficult for him to reach from here to here. Fine. So the major disadvantage of this is it quite large area and the pedestrian traffic is large, then the rotary should not be provided. Fine. Now, what you have to do is that in the question, in the examination, what they can ask, they will ask you to calculate the capacity of the traffic island, or they can ask you to calculate the weaving ratio. So we will understand both the cases. Fine. So let's first of all draw the rotary island to understand these cases. Let's draw a rotary island here. इसको ध्यान से समझना. This is a little complicated. If you will be able to understand it properly, it will be very easy for you. जैसे समझा रहा हूँ वैसे ही पढ़ना है, कुछ और कॉन्सेप्ट अपना नहीं लगाना है. जैसे सिखाया जाएगा वैसे ही सीखना है. ना बुक को देखना है, ना किसी और को देखना है. सिर्फ ये वीडियो देखना है और वही देखते जाना. उसी से सब समझ में आ जाएगा. See this. This is an intersection that we have created, where 4 number of roads are intersecting. Let's number these roads. This is road number 1. This is road number 2. This is road number 3. We are numbering it clockwise because the traffic will be moving clockwise. 4. Now, what exactly we want? We want an intersection should be present. This is an intersection. We want an island to be present. Let's say that this is a rotary island which is present in between these roads. This is a rotary island, raised portion. This is a raised portion which is present here. Now, what is weaving? I just told you a term weaving. Weaving means the movement like this, which is a crossing movement. This is weaving. Silte hai na kapda? This is a weaving. This is weaving. Traffic which is moving or crossing like this, that will be known as the weaving traffic. Now, what exactly is the weaving ratio? Let's see that. What is the meaning of the weaving ratio and what exactly is the weaving ratio? Weaving ratio से पहले इसको सीधा करेंगे. ये टेढ़ा हो गया, इसको सीधा करेंगे. अब सही देखो. Now we want to calculate the weaving ratio. For the calculation of the weaving ratio, just remember one thing. The traffic will be coming from here and it has to move like this, which is in clockwise direction. There will be a channelizing island present in each and every zone here. There will be a channelizing island which will be present here. जो चारों road पे present होगा, it will be present in all the 4 roads. Now, what exactly is happening? This is allowing the traffic to move like this, and this is allowing the traffic to come back like this. This will be the case. Fine. Traffic will be moving and coming back. Now, what will be the case is that this is the weaving portion. Now, this is the weaving movement. Now, weaving movement can only be present either in this zone, or in this zone, or in this zone, or in this zone. It means that if you will see this particular figure in a 4 road intersection, there will be 4 different types of weaving zone. Weaving can be present here, can be present here, can be present here, can be present. Weaving cannot be present here. Weaving cannot be present here. Weaving can be present only here because the traffic will move like this. Whenever the vehicle will be coming from this direction, then only the weaving is possible. समझ में आ रहा होगा. If this traffic is moving like this and the traffic is coming from here, then there will be the case of weaving. There he cannot weave because the traffic has to cross. It means that the weaving portion can be this zone, this zone, this zone, or this zone. Fine. Now, what is weaving traffic? Or weaving ratio? What is weaving ratio? Weaving ratio is basically the ratio of the weaving traffic. The ratio of the weaving traffic. Weaving traffic means weaving vehicle. जो भी vehicle weaving कर रहे होंगे, उन सब का ratio, number of vehicles divided by the total traffic. Divided by the total traffic, which is calculated for different zones. It means that weaving ratio for this zone, this zone, this zone, and this zone. In this particular intersection, you will calculate 4 different weaving ratios depending upon the amount of traffic weaving in that particular zone with respect to the total traffic that is present on that particular zone. This is known as weaving ratio. Fine. This weaving ratio has a value lying between 0.4 to 1. This is denoted by a small p. The value can be between anything between 0.4 to 1. Now, let's see that how to calculate the weaving ratio. First of all, you have to consider 2 zones at a time and those roads, 2 roads at a time, and those roads should be adjacent roads. Which means that if you want to calculate the weaving ratio, so either you can consider 1, 2, or 2, 3, or 3, 4, or 4, 1. You cannot consider 1, 3. You have to consider adjacent roads. Fine. So what we are considering 1, 2 as the roads for the calculation for the weaving ratio. Let's see that. Between 1 and 2, just remove that so that we can have a better clarity. Between 1 and 2, what we'll do is that we will just draw the different types of movement, whatever the movement that can be possible between this zone. In this zone, let's consider this is the weaving zone which we are considering. This weaving zone is having a length of, let's say that L. L is the length of this weaving zone. L is the length. And let's say that the width of this weaving zone is W. The width of this zone is W. So what we are doing is that we are considering this zone. So what we'll do, we'll just write all the movements which can be possible in this zone. So we'll start with this. The movement can be, the vehicle will come from 1 and it will go into 2. This can be the movement. This is one type of movement. Let's say that this is movement A. Movement A is what? Movement A is what? Movement A is that movement in which the vehicle is starting from 1 and it is ending into 2. 1 se aaya, 2 mein chala gaya. This is, we are denoting it with A. Fine. Another type of movement in which this zone is involved is that the vehicle will start from 1. It will not go into 2. It will go anywhere else, but not into 2. 2 में नहीं जाएगा, बाकी कहीं भी जा सकता है. Let's say that this is B. It means that it can go into 3. It can go into 4. And remember that it cannot come back into 1. जो 1 से निकला दोबारा 1 में नहीं जाएगा. इतना पागल नहीं घूम के जाएगा भाई, यहाँ से घूम के फिर 1 में जाता हूँ, यहीं से झूठा मार के चला जाएगा. It means that the vehicle which is starting from 1, either it will go into 2. When it will go into 2, clockwise movement is only possible. Then you will consider it to be, number of vehicles to be A. When it is starting from 1 and it is going anywhere else but not into 2, that will be 3 or 4 but not into 1. It cannot come back again to its initial position. Then you will consider it to be B. Fine, this is B. So these can be the two movement which is possible from 1. And it is crossing this zone. Now, there can be another movement that will be denoted by C, that the vehicle is coming anywhere but not from 1 and that is exiting into 2. This is C. मतलब vehicle पीछे कहीं से आएगा और 2 में चला जाएगा. 1 को छोड़ के, 1 में नहीं जा रहा, पीछे से कहीं से आया और 2 में चला गया. 1 से क्या हो सकता था? The possibility is 1 से निकल के 2 में चला जाए या 1 से निकल के कहीं और चला जाए. यही पॉसिबिलिटी हो सकती थी और 1 से कुछ नहीं हो सकता. अब आपने क्या किया? आपको जोन क्रॉस करानी है. पॉसिबल ये भी हो सकता है कि 1 को छोड़ दो, पीछे कहीं से आए. पीछे कहां से आ सकता है? 4 से आ सकता है, 3 से आ सकता है. पीछे कहीं से आए, 1 में ना जाए, क्योंकि जोन क्रॉस करानी, 1 में चला गया तो जोन क्रॉस नहीं होगी ना. वी हैव टू कंसीडर दिस पर्टिकुलर जोन बिकॉज यू कैलकुलेटेड द वीवी ट्रैफिक. दैट वीवी ट्रैफिक कैन बी कैलकुलेटेड फॉर अ पर्टिकुलर जोन. तो यहां से ट्रैफिक आया और इसमें चला गया, जोन क्रॉस हुई. हियर इफ यू विल सी दिस, if you see this properly, watch it properly, this is a crossing point. It means this is a movement like this. It means that there is a weaving case. What is weaving? Weaving is between the B number of vehicles and C number of vehicles. Fine. So this can also be the movement. Now, let's consider one more movement which can be possible. The movement can be, the vehicle is coming somewhat from here, पीछे से आया, 1 में तो जाना नहीं है, पूरी जोन क्रॉस करी, 2 में भी नहीं गया और आगे निकल के कहीं भी जा सकता है. मतलब पीछे से आया, क्रॉस कर गया पूरी जोन, 1 में तो जाना नहीं था, 2 में भी नहीं गया, 2 में जाने वाला C था, आगे कहीं निकल गया. लेट्स से दिस इज D. ये कैसा हो सकता है? मतलब 4 से आया, 1 में जाना नहीं, जोन क्रॉस किया, 2 में भी नहीं गया, 3 में चला गया. तो 4 से आके 3 में जाने वाला, दिस कैन बी द D. It means that these 4 movements can be the maximum number of movements which can be present in this weaving zone of width. Let's say that the width of the weaving zone is W. In this W width of weaving zone and L length of weaving zone, the maximum number of movements can be A, B, C, D. What is A? If you are considering zone 1 and 2, you can consider 2, 3 also. Then you have to maintain the same procedure. 2 से start होके 3 में गया, 2 से start होके कहीं और गया, पीछे से आके 3 में गया, पीछे से आके कहीं और गया. सेम वे केस करना. 1 से आके 2 में गया, 1 से आके कहीं और चला गया, 2 में नहीं जाना, फिर पीछे से आके 2 में गया, पीछे से आके कहीं और चला गया. These are the 4 type of movement. In these type of movements, if you say that the total traffic, if you want to see the total traffic, then the total traffic will be total traffic. The total traffic will be A plus B plus C plus D. This will be total traffic. Now, if you want to see the weaving traffic, now what will be the weaving traffic here? The weaving traffic is basically here is B and C. This is a weaving traffic. If you want to calculate the weaving ratio, this will be B plus C divided by A plus B plus C plus this. This will be the weaving traffic. Fine. This is the weaving ratio. This is the weaving traffic. This is the total traffic. This is weaving ratio. Now, what is A? A is the vehicle which is starting from 1, entering into 2. V12. What is B? B is the vehicle which is starting from 1. It is not going into 2. कहाँ जा सकता है? It can end up to 3. It can end up to 4 also. C is the vehicle which is coming not from 1, from somewhere else, but it is entering into 2. So this can be the vehicle coming from 4 entering into 2. Clockwise आके आएगा. Vehicle coming from 3 and exiting into 2. This can also be the possibility. 3 से 3 में नहीं जा सकता. 3 से 4 में जाएगा, उससे मतलब नहीं, because we are considering this zone only. Now D is the vehicle which is coming somewhere behind 1 and it is crossing the zone and coming like this. So D can be vehicle which is coming from 4. 4 से आया, 1 में नहीं गया, zone cross किया, 2 में नहीं गया, 3 में चला गया. और कुछ हो सकता है. 3 से निकला 4 में, 3 से निकला 1 में, 3 से निकला 2 में, 3 से निकला 3 में नहीं आ सकता. It means that D can not consider 3. समझ में आ गया. These are the movements. Now what you have to do is you will be provided with number of vehicles आपको provide होंगे, सबको add कर देना, यहाँ put करना, you will get the value of weaving ratio. Fine. Weaving ratio हो गया. Now sometimes they can also ask you to calculate the capacity of the rotary, the capacity of the traffic rotary. Now how to calculate the capacity of the rotary? To calculate the capacity of the rotary, there is a relation. That relation says that the capacity of rotary is equal to 280 into W, which is the width of the weaving zone. Remember that. 1 plus E by W. I'll just let you know what is E. 1 minus P by 3. P is the weaving ratio. Divided by 1 plus W, width of the weaving zone. L, length of the weaving zone. Now, here, if they will say that in the question, if they are asking you weaving ratio, then they will provide you कि weaving ratio किन दो रोड के बीच में निकालना है, like calculate the weaving ratio between 1 and 2, like this. Fine. But if they are asking us to calculate the capacity, then what you have to do is that you have to calculate the weaving ratio considering all the zones with 2 at a time, like 1, 2, 2, 3, 3, 4, 4, 1. 4 weaving ratio निकालोगे, you will calculate all the 4 weaving ratio, and then out of those 4 weaving ratio, the maximum value we will use here in this formula to calculate the capacity. Now, for rest of the values, E is basically equal to E1 plus E2 by 2. Now, what is E1? E1 is the width at the, this is E1. E1 is the width at entry. E1 is known as the width at entry. The minimum value of this is 5 meters. And it depends upon the approach road width. It depends upon the approach road width, which means that if you have to just consider a table, this is approach road width, and this is E1 value. If the approach road width is 7 meters, this will be given to you. Then you have to consider E1 is equal to 6.5 meters. If the approach road width is 10.5 meters, then you have to consider E1 equal to 7 meters. If the approach road width is 14 meters, then you have to consider E1 is equal to 8 meters. If the approach road width is 15 meters, then you have to consider E1 is equal to 10 meters. Now what is E1? Just see that in the figure. E1 is this value. This is E1, which is width at the entrance or entry. This is E1. Now what is E2? E2 is the width of the non-weaving section. This is E2. यहाँ पे weave नहीं हो सकता ना? This is E2. यहाँ पे weave नहीं हो सकता. यहाँ पे weave नहीं हो सकता. यहाँ पे weave कहाँ हो रहा है? यहाँ पे कहीं हो रहा है. It means that E2 is the width of the non-weaving section. जिसकी value you will be provided directly. E2 is this is the width of non-weaving section. Non-weaving section. This is the width of non-weaving section. This will be provided to you. ये given होगा question में. अगर given नहीं है, then you have to consider E2 is equal to E1. And if it is not given, then you can consider E2 is equal to E1. Length will be given. Width will be given. अगर width given नहीं है, then width can be calculated as E1 plus E2 by 2 plus 3.5. It is not given, you can calculate like this. If L is not given, then you can consider it equal to 4 into W, which is the minimum value of length of weaving zone. That is equal to 4 into W. This capacity of rotary, which you will calculate, this value, in any case, for a proper design of rotary, as per IRC, should not be more than 3000 vehicle per hour. सारी रोड्स को ले लोगे तो मैक्सिमम कैपेसिटी फॉर द रोटरी इज 3000 व्हीकल्स पर आवर. इफ दिस वैल्यू इज बीन एक्सीडेड, देन रोटरी कैन नॉट हैंडल द गिवन traffic. So this value should not be 3000 vehicles per hour. If it is getting more than this, then in the question at the end you have to write that this rotary cannot handle the given amount of traffic. So this is the rotary design. समझ में आ गया होगा. The most important is the weaving traffic. 1 से निकल के 2 में गया A, 1 से निकल के कहीं और गया B. अगर यहाँ 5th भी होता ना तो B में ये भी आ जाता 1, 5. 1 से 3 में, 1 से 4 में, 1 से 5 में. What is C? C पीछे से कहीं से आया और इसमें चला गया, 2 में चला गया. अगर यहाँ 5 भी होता तो 5 से 2 भी लिखते आप फिर यहाँ पे C में. ठीक. D का मतलब 1 पीछे से कहीं से आया, क्रॉस करके पूरी जोन आगे निकल गया, 1 और 2 को छोड़ दो फिर, ठीक। अगर यहाँ 5 भी होता तो फिर आप 5 से आता वो 5 से 3 में भी जा सकता था, और 5 से घूम के फिर वो 4 में भी जा सकता था, तब भी दोनों में जोन क्रॉस हो रही थी, समझ में आ गया। तो वो दोनों चीजें भी डी में आ जाती। फाइन, आई विल गिव यू द क्वेश्चन टू प्रैक्टिस, जस्ट रिवाइज it once, just write it on the paper so that you can easily revise it. You should not watch the videos again and again. If you want, you can watch it again and again, but it will be easier for you if you write it down on a paper. I hope that you have understood the cases. It's AS Pandit signing off this session. Take care. Bye bye. Have a nice day.